On to our next keynote now. This with Rohit Sinha, Global Head Cloud and Modernization Practice at Genpact. This is fantastic, actually, really. It's how cloud and 5G are fueling each other's growth, which, as you've seen from this whole event, they are all so inextricably linked. Rohit, great to see you. How are you?
I'm doing good. How are you?
Yes, really good, thank you. It's been the absolute theme of this show today, and your presentation completely fits in with that. So really looking forward to seeing what you've got for us, and I'll be back with some questions at the end. The virtual floor is yours.
Okay. Thank you so much. So hello, everybody. This is Rohit Sinha, as was introduced by Neil, that I head Genpact's Cloud and Modernization Practice. What I'm going to do today, I'm going to invite you on a journey to go from a world that was sort of disconnected to where we are able to exchange information seamlessly, and not only seamlessly, but also we are processing and making that data available real time. It might sound not so long ago when the information exchange used to take days, sometimes months, but now it is real time, right? So please join me in that journey, what I call it as information era. We are all aware that this information era started sometime in middle of 20th century. Before that, the communication was through telegram, through snail mail, papers were sent through messengers, and so on and so forth. But then with the invent of internet, what it gave rise to very seamless information exchange. And I'm talking about fixed line communication. We started with dial-up. I'm sure a lot of you recall how that network was and what it entailed and what was the speed at that time. People had a little bit more patience, probably I should say a little more than a little bit. We actually lived in that time for a long few years, where if you have to exchange information or you have to go online, you have to dial up through telephone line, and then we all remember those music that was played when it was dialing, and then you're online. Then comes the DSL, where it was always on, always connected. And then fast forward to a broadband with cable and fiber. Now we pretty much take internet for granted. It's like electricity. It's always there. You flip the switch. In case of internet, you do not even have to flip the switch. It's always there. Now, if let's draw a parallel. Let's go on the side and let's talk about mobile network. So this was a fixed line. We were still using Wi-Fi. We were still using internet and so on and so forth. But we were not happy, or we were not satisfied. We were happy. We were not satisfied, saying, when I have to access internet, I have to be at home or in cyber cafe or in office. Why can't I use internet when I am outside, when I am in motion, when I am mobile? There comes the world where mobile internet was just shaping up. And this is way back in, I think, 90s and early 2000, when 2.5G, what we used to call it as a GPRS, came into play. And it was pretty impressive of how we can access internet through mobile. However, there were not many content out there because the screen size of the phone was much smaller, and there were not many content that could be consumed on the mobile device of that era. And hence, there was a different protocol was introduced for just information exchange, WAP protocol, and then there was a markup language of wireless markup language. Then, it sustained for a few years. But it was very clear that that model of content sharing is different on mobile phone versus your desktop or a laptop computer. Those content has to be generated separately, consumed separately, and so on and so forth. That was completely non-sustainable. Oops, sorry. That was completely non-sustainable. So when 3G came into being, that was an attempt not only to provide higher speed internet on mobile, but it was an attempt to combine these two worlds of fixed line internet versus mobile internet. The content to be different was a problem, and that was identified very easily and early on. The promise of 3G, and there were a lot of content being planned and so on and so forth. It was, if I recall it correctly, 384 kbps. It said that is fabulous, but it had a little bit of issue. And this went on. I mean, the launch of 3G was early 2001 by NTT Docomo in Japan, but that was a very, I wouldn't call that as a global release. Global release did not happen until 2002, late 2002 and 2003. But the promise of faster internet on 3G did not become reality. It was launched with a lot of fanfare, but the speed, the sustainability of multiple users on the network and so on and so forth did not happen until LTE was launched in 2009. And LTE has seen convergence of CDMA and GPR or other network. And when, fast forward now with 5G, speed, we are actually seeing much more speed than the fixed line. And that's a topic for right now when we are talking about what is possible, what can we do with 5G. So that's a journey we have seen in the information era, where we went from fixed line, the slowest possible network, to broadband. And then in parallel, mobile network also went through a similar journey, where it went from 2.5G all the way to 5G. And now 5G is challenging broadband network as we speak. So I'll probably move to data era. Well, I'm saying data era, we are still in information era, but there is a lot of progress that is happening or that has happened in past decade or so. There is focus on data. There is significant focus on data, not only utilization, but also monetization. And I sincerely believe that cloud is instrumental in causing this growth. And how so? I'll probably explain myself a little bit. Probably before cloud, what used to happen is whenever I have to process large amount of data or I have to do large calculation, I need a powerful machine. And most of the time, all those powerful machines are with the universities. Commercially, only few companies had those large machines because of the fixed cost that is required to actually buy those machines. It was pretty expensive. And all this calculation was probably one-time need in maybe once in a week when you do the calculation, you do the iteration and so on and so forth. So it was kind of cost prohibitive. And cloud has enabled that where you could buy the burst capacity and so on and so forth. So with elastic on-demand infrastructure, this high capacity machine became accessible to masses, and hence processing large amount of data became much easily available to everybody who wanted to process the data. And this has given rise to not only data being available, but insights generated that was unthinkable a few years ago. What can you do with large amount of data and generating insights out of it? And I think cloud has lots to do with it. And we know that hardware capacity doubles every 2 years, which means we can pack more transistors in the same area, and it doubles every 2 years. But then the demand is also increasing in the same pace. My hardware capacity increases, but we as human beings, we are able to find what we can do and more with that capacity. And that's when all the AI and AI model and generative AI, everything what you are seeing right now. And that's the possibility of how we can utilize that increase hardware capacity and such. Right now, the place we are in, the data is being produced as fast as it is consumed, as well as the consumer of the data getting all that data almost at the real time, but near real time, I would say. And I'm talking about the time before 5G right now. We must have heard that it's always near real time. You ask 5 question or 5 why, you will know that most of the implementation, even today after advent of 5G, is still near real time, not completely real time. So now let's see how, when I put cloud and 5G together, what are the things that are possible? And I'll probably go through just 2 or 3 use cases, not getting into a lot of details of each, but let me take you to the final step in my journey. When we are talking about cloud and 5G, what it is making or how it is making unthinkable possible. Let's talk about automobile industry. All of us are aware of autonomous driving. Some of us might have experienced as well. Now, let me take a step back and give you a number. If I look at 2024 numbers of fatality or the because of traffic crash, National Highway Traffic Safety Administrator has released those numbers. Around 29,000 of first 9 months of 2024. And that has reduced by 4.4% as compared to similar period in 2023. And this has happened by just few interventions that was introduced by automobile industry. Is anti-collision warning. All of us must have experienced this. Is you do not need autonomous driving for this. Most of the car come with this safety feature that either it will slow you down or it will give you a beep or so on and so forth. Where whenever you are in a path of collision, it has mechanism to alert. Now think about what if all the cars on the road are able to talk to each other. And that is exactly what I'm talking about when I'm talking about vehicle-to-vehicle communication. Imagine when you are at a signal and your car can talk to signal and understand whether to stop because of the distance you are traveling, at the speed at which you are traveling, and how much time that signal has before it turns yellow and then red. Or for example, you are standing in a traffic and your signal is about to turn green, your car is automatically, if it is autonomous driving enabled, can go and start. Or it is bare minimum, it is able to alert you saying it's green, you have to go. It's not only avoiding crash, but it is making you a little bit more efficient. And those are the things I'm talking about when I'm talking about vehicle to network communication and vehicle to infrastructure communication. And that is a art of possible because of real-time communication that is enabled by 5G. The previous network, the quality of service was not as great as 5G. 5G has improved it multifold. And now we can rely on 5G for those critical communication. All the information can be sent to cloud in real time, and cloud can scale up and process the data and send it back down again in real time. Of course, processing will take some time, but the communication itself is real time. Now let's take another example of manufacturing industry. And this is probably a lot of debate happening here, that how do we actually implement just-in-time inventory? We all know if you are running a business, the inventory that any business has to maintain defines how much of a money that is locked in. And the lesser the inventory, the more efficient that business is, and so on and so forth. And that's why some of the companies are more efficient when they are able to produce things only after they get the order. But reality is every industry cannot do that. How much time are we spending in getting the order, getting that onto shop floor, from shop floor, looking into the inventory and so on and so forth? How about if I say that this will become pretty instantaneous? Can your vendor who is supplying your raw material will appreciate that the lead time they are getting is pretty small as compared to what they are getting right now? I do not have to give order 2 weeks in advance and then wait that much time for my raw material to come and then produce and so on and so forth. It will potentially reduce the inventory that I'm carrying. How about when my assembly line fails in some point? How much time does it take to get notification? As we all know, even if it is delayed by few minutes or few hours, it can cause a lot of issues down the line. Now we are able to reduce all of those. using real-time communication of 5G. As I spoke earlier about communication industry, home internet is also challenged by 5G now. Few years ago, I have tried it, and it was pretty impressive what it could do. Another thing is private 5G. And this is pretty interesting concept. Imagine you are deploying a new factory. Nowadays, most of the assembly line is automated. It definitely needs connectivity. It definitely needs communication channel, not only to people, but also to different machines. Before 5G, the only possible thing was to lay cable, connect everything through Ethernet cable or Wi-Fi. Wi-Fi, as we all know, you need a lot of repeaters in between. Its range is not that high, and so on and so forth. But today, we can actually install 5G, and you can just insert a SIM card on your machines, and then it is ready to go. And this private 5G cloud has made it so simple that they will ship you a device. You just place that device in the premise, go onto the cloud, and instantiate your private 5G network. So that's the art of possible. And of course, there are a lot of things that this combination of cloud and 5G opens up for us. With that, thank you so much.
Indeed, covered a huge amount in 20 minutes there, and it's so exciting when you take a little step back and look at all of the developments there have been. Well, the future is something we've looked at a lot here. We're looking there at the present and the advancements there have been. What are the next steps for you? The two technologies are continuously challenging and pushing each other to come up with the next innovation. Where do you see things going next?
Well, the way I see it is the evolution of mobile network. I've been closely following it. I think it's gonna keep increasing the speed. It will keep increasing the use cases and so on and so forth. And we have just barely started to see what cloud and 5G can do together. IoT world, think about a remote area where diagnosing issue. I mean, one of the example I can talk about probably is oil drilling rig. Now, can we remotely diagnose and fix the issue? Remote surgery. It has been there for quite some time. But with this real-time communication, all of those use cases will actually get a boost. I think the sky is the limit where we can bring up use cases and such that will change the way we are thinking today.
Yeah, we are very much still at the dawn of this particular technology, even though it feels like it's been with us for a while. The use cases are so exciting. Okay, well, we're going to have to wrap things up there. Thank you so much for joining us here at Cloud and 5G Live. Really enjoyed your presentation. Thank you, Rohit.
Thank you.
Thank you. A pleasure.